lab really focuses on NMN. And I think if people were sort of like following what you said earlier about how NR turns into NAD, they might go, oh, well, NR turns into NMN, NMN turns into NAD, so why don't we just take NMN to begin with anyway? And you had mentioned earlier phosphate, and that's an important component of this question.
Well, it is. NR is more popular because it's cheaper to make. It doesn't have that phosphate, which can be expensive to put on the molecule through chemistry. And that's why most people started using NR first in humans and in mouse experiments. I didn't have a horse in the race. I didn't care which one. In fact, I'd prefer if both worked according to my theories. But what we found through empirical studies, basically we're looking at which ones work better. My lab and others, including Matt Kaberlein, who's at WashU, who treated a mitochondrial disorder, and we were treating regular mice on treadmills, we found that NMN just worked better at the same dose. We don't actually understand why. It could be that this phosphate addition is one of the reasons. But, just based on observations in our hands and in others, NMN works better than NR.
When we supplement with NMN, when NMN is given to organisms in the lab, what's happening?
Well, it's a little different. There's been an argument in the literature that NMN doesn't get into cells. And similarly, NAD is really a big molecule because it's got multiple components. And that also has a real struggle to get it into cells. Neurons take it up, but other cells typically need to break it down into its various components and then re-uptake it. And that's important because some people actually are giving themselves NAD through the IV route. When it comes to NMN, what happens is it was recently discovered by Shin Imai at WashU. His team discovered that there's a specific transporter that takes NMN out of the liquid outside the cells inside the cell, and its name is SLC12-8A. Still debated, a lot of things to figure out, but I think it's just best to say, okay, we know what's happening when you give it to animals. We're starting to learn what happens to people. We, of course, want to understand how it's working, but the fact that it does work is the most important point.
So when it comes to NMN, there's been a number of animal studies showing, for instance, similar to NR, it restores NAD levels, it enhances insulin sensitivity. One of the things that was surprising to me is that we don't have a study that shows NMN's effect across the mouse's entire lifespan yet.
Yeah. Well, we have half a lifespan. Shin Imai showed that it actually was pretty good at slowing down the effects of aging, but he stopped the experiment because he ran out of NMN. It used to be rare stuff. Now you can buy it. But we took up the challenge, and we've been doing these studies for the last few years in my lab. Now, preliminarily, these mice have less frailty. We've reported that out in the scientific community. They seem to be younger, having better activity, better mitochondrial function. They run further. The lifespan looks promising. We've done it once, and they do live longer on NMN. The doses are about 400 mg per kg.
How much longer?
At this point, by recollection, is about 10 to 15%, but particularly strong in females.
Okay, so not particularly like wholly different than what we saw in the NR cases with the mice.
Right, a little bit better than that, but certainly those mice are healthier and more active and are more youthful.
And you said it's more pronounced in the females, or at least according to the first phase of this, it's more pronounced in the females.
Right. Well, we had fewer females, so we have to repeat that. So we've now got a larger cohort of mice. We're repeating the whole thing. We'll see how it goes. But right now, with the small number of females, yeah, they did do better than the men.
And even though mice live pretty short lives, what we have to understand here is that they still live 2-3 years on average, right? And so in order to see lifespan extension, especially if they live much longer, it takes some time to do these studies.
Yeah, it's quite painful actually, because you think about this, an average experiment takes 3 years, and then you have to repeat it. So that's now 6 years. Then to analyze the data and publish it is another 3 or 4. That's a decade's worth of work for one experiment. And your career only goes for about 5 of those times. So 5 experiments. Of course, you can run.
Well, that's how careers
parallel.
used to go. We're going to change that, right?
We're going to live a lot longer. We run things in parallel as well. That's important.
Yeah.
But we can also mimic things, not just in animals, but we're growing tissues in the dish will be the subject of a later episode.
Okay, so far what I'm hearing is in animals, NR and NMN both have some similar effects, right? Lengthening lifespan, restoring mitochondrial activity, restoring NAD levels, enhancing insulin sensitivity. But in NR, the human studies haven't always confirmed that that's the exact same thing that's happening in humans. What are we seeing in the human studies for NMN?
I know a fair bit about the effect of NAD boosters in humans because I'm helping a group that is actually doing clinical trials at Harvard Medical School. And they've been giving a molecule that's similar to NMN to subjects for many years now. First of all, importantly, there's been no evidence of any negative side effects. That's important. And we're about to learn whether it actually does anything that's similar to the mice. We don't have results in yet, but hopefully by 2022, we'll actually know if people have more energy, more mitochondrial function, better blood flow, more endurance, which is what we saw in those mice.
There's been a little bit less human research on NMN than in NR, but we're starting to see just in the last couple of years, especially sort of a flood of studies being published. Early results, for instance, from Yoshino et al. In 2021 showed increased insulin-stimulated glucose disposal. We talked about this a little bit when this study came out. You were pretty excited about it. Tell me why.
It's one of the first real proofs that NMN does something in humans the way it works in mice. So this was a 10-week study. It's well done. It's randomized, placebo-controlled. It was 250 milligrams, which is a relatively low dose. Remember, I'm taking, and my clinical trials are 1 gram and 2 grams. This is 250 milligrams. Nevertheless, it improved what you said, insulin-stimulated glucose disposal. That's basically insulin sensitivity. And that's a hallmark of longevity. Keeping the glucose out of the bloodstream, keeping it low levels, is a hallmark of wellness and ultimately longer life. So that's the beginning, but we have a lot more to figure out. We need to figure out if that increased endurance that we see in my lab with NMN-treated mice is true for humans. We also want to know, are organs protected? Other labs, not mine, but other labs have shown that NMN protects the organs when they're damaged, kidney and heart, the two main ones, even increased wound healing. I'd love to know if NMN does that in humans. That'd be a big deal. Kidney injury is huge. And particularly, I don't know if you know this, but most surgeries on the heart end up damaging the kidneys, and there's not much you can do about it. So ultimately, we've seen a glimpse with Yoshino et al. My studies that I'm involved with at Harvard Medical School are looking promising. We'll know more next year. But yeah, there's a lot more in the work.